question that you may have. So if you do have a question, please use type in the question and answer board, and we will be answering those questions once we finish the presentation and we go through the Q&A. Just to confirm, can you hear me?
Yes, Henio,
Yes.
perfectly.
Yes.
Okay.
Yes.
Okay, thank you. So presenting to you today will be myself. So my name is Henio Alberto. I am the Reservoir Engineer Technical Consultant for SAS Schlumberger, covering the Sub-Saharan Africa countries. And also we have Ndivhuwo Nemekon, which is a reservoir engineer located in Cape Town. So our agenda for today is focusing on the RE station suite, and we'll be looking to the material balance plugin within the station suite, and also the EOR plugin we have. Now, what is the Reservoir Engineer Station Suite? And to answer this question, so it is a combination of different softwares that before were separate plugins, but now they are all connected and implement inside Petrel. So they're still being plugins, so we have to install them in your existing Petrel if not done already, so that you are able to use them. Now, since 2018, these plugins have been made available in Petrel, and there is no cost associated to any of you that is using Petrel, both with the Reservoir Engineer or the combined core. So there is no charge to have this station suite to you, but it brings a lot of more advanced workflows which can complement the activities and the studies that you do within your fields and your assets. So the main focus for now, for this first part of the session, will be the material balance. So the material balance has been included into Petrel since 2018. And the next one I'll cover as well in the middle, as I completed, will be the EOR S&D. Although there are two more station suite plugins. One is the hydraulic fracture modeling, which allows you to to modeling fractures nearby your wells and not only, and geoscreening, which will be covered in a different session. So geoscreening is a plugin that allows you to select and filter different geological models according to their mobility and uncertainties, P10, P50, P90. So my main focus right now for the next slides will be the material balance for this session. Now, before I go to the details, I just want to do a brief introduction into the concept, mainly explaining what is the material balance. So it is an analysis that allows us to be able to understand what are the main drive mechanisms that are being present in a reservoir. Moreover, to understand the hydrocarbon volumes that we have in place. So material balance is an analytical method, and it is a method that is available in our industry since the beginning of the hydro studies. Yeah. But bringing material balance to Petrel allows us to be able to quality check what is the normal analytical material balance response of a reservoir, make us be able to understand and validate the main drive mechanism we have in our reservoir, and also compare with our numerical simulators, could be Eclipse and Intersect. So the data we need for material balance is basically the PVT data, which is the main characteristics of the fluid, and production data. Through that, using the material balance equation, we will be able to create different plots, which will allow us to understand the dynamics of this reservoir or of this tank model. So through that, we will create diagnostic plots, define the drive mechanisms, in-place volumes, and pressure. Now, going a little bit more into detail on the material balance concept, is all based on the preserve of the mass. So in our reservoirs, we may have an oil reservoir, a gas reservoir, or a reservoir that have oil and gas and an aquifer. As we start producing this reservoir, we will have pressure depletion happening in the reservoir. And this pressure depletion will lead to expansion of the fluids that we have in place. That is for the gas cap, if present, for the oil and its dissolved gas, and also the connect water, or even an aquifer influx. Also, as the pressure is decreasing in the reservoir, we have the expansion of the rock itself. So, be able to understand how these different components impact the material balance. We have here the material balance equation, which is a conservation of the mass. And here we have the understanding that everything we will produce, which is the oil and the dissolved gas, the water production, and if you have injection happening in the reservoir, water injection or gas injection, so that will be direct link to an expansion in the reservoir of the oil and gas, compression of the pore space, connect water, gas cap expansion, and even the influx we have from the aquifer. So material balance we use through this equation, we will be able to address and understand what are the main drive mechanisms that are giving energy and we allow which we allow to produce our reservoirs. The main drive mechanism that we have to model in material balance are: number one, solution gas drive, which mainly for reservoirs which the pressure goes below the bubble point pressure, and then we have gas coming out of the oil. Initially, this gives a good drive for the production. Gas cap expansion for reservoirs that have gas cap or even secondary gas cap, if that come. Natural water drive, which is from aquifer influx, especially when we have a strong aquifer influx. We have fields today that even without having injection are actually being maintained for many years because of a very strong aquifer. So it's very important to be able to model that. Compaction drive, and of course gravity segregation, mainly when we have different fluids or gas and water. If we're injecting, depending on their density, they will segregate, and that also leads to some motion. So those are the main drive mechanisms that can rule the reservoir, and it's very important to understand them because they will impact which mechanism we will use for secondary recovery. Now, the material balance plugin inside Petrel allows us to identify these main drive mechanisms and also the hydrocarbon in place, either if it is oil or gas. In order to be able to create the material balance model inside Petrel, we use the main data we require, which is production data and static reservoir pressure. We know for some old reservoirs, static reservoir pressure can be a challenge, but those are the main required inputs to have a valid and accurate material balance model. And through graphical methods, we will be able to create different plots, energy plots, Havlena-Odeh plots, PZ plots, which will allow to understand the drive mechanism and the fluid in place. Although having this in Petrel is good because we allow us to have an additional tool which can help us through the history matching process. Now, going quickly to the value of the material balance plugin, so allows us to have and be able to do a better characterization of a reservoir. And through that, be able to match the history and also the reservoir pressure. But doing this, we will understand what are the main drive mechanisms that are in place in the reservoir. And why that? Because sometimes, for example, we may be injecting water in a reservoir, but our water injection may be bypassing our main oil and not contributing much to the pressure maintenance of the reservoir. Be able to calculate material balance, we can see the impact of the water injection, for example. So all of these are important parameters that we can be able to revalidate using an analytical method like material balance is. Another big challenge sometimes we have is understanding what is the original and the real oil in place or gas in place in our fields. Sometimes we have reservoirs producing for many years, 20, 30 years, and achieving recovery factors of 80 and 90%. That could be, number one, either we implement a very good recovery strategy, which allow to have that high recovery, or our in-place volumes are slightly different than the one reported. So material balance will help us to try to understand these dynamics, original fluid in place, and also cross-validated with our numerical simulators. Another big value of having material balance inside Petrel is that we can use Petrel itself. We can use the geological grids that has been created. The static model in Petrel has an input to our material balance. We can use the PVT data in Petrel as input to our material balance equation. So that speed up the process of modeling your material balance. And we show that in the next slides. The type of reservoirs we can model now inside Petrel with the material balance are gas reservoirs, gas water, oil, gas, and water reservoirs. Now here, I would like to show you the interface in Petrel and where can you find the material balance plugin once it is installed in your machine. So if you go to the production tab here on the top, then you have in the material balance section, which is here composed by three main process. And to create the tank mode, you select tank mode and you have this window open. And this is where we will input the information required for material balance. This is the reservoir properties and also the historical data. Now here we will put the main fluid, for example, the oil, using the existing fluid model inside Petrel, the reservoir properties such as pressure, temperature, GOR, water compressibility, and also we will be able to characterize the volume of the tank. And that will be shown in detail to the following demonstration that will come. Now, going to the material balance process, so it is divided in three main steps. First is to create the tank model, which allows us to input all the information required to characterize this tank. Then we will have to calibrate that if it's not matching with the historical data, which is the pressure. And we'll be able to analyze the main results of this, which is using the energy plot, the Havlena-Odeh plot, and the PZ, as I was mentioning. And the process is, as you see here, on the left-hand side. Now, look into the input parameters. It's very important that we're able to validate and QC the input data we use in this model. Having your input data in Petrel can speed up this process because maybe it has already been cross-validated and review has it been using in your present model today, either Eclipse or Intersect, and that data can directly go into your material balance. So this is your fluid model, your reservoir. So if your field has an aquifer, for example, a Fekovic aquifer, we're able to model that as you show in the next steps, and also the main observed data. So all of these, which already reside inside Petrel, in the stub, we were able to input that to model your material balance. So in here, this is the main tab where you add in the information. A very good thing is that you are able to select different units as part of your input data, so you don't have to convert everything to a standardized metric of field. So you have the flexibility to do that, which will be shown also in your demo section. And you can model oil and gas reservoirs. You have to select either one or the other. You can specify detailed inputs such as your main compressibilities, raw compressibilities, or you can let it be calculated. And also you can select different types of volumes input methods. Could be a grid or could be specified, and define different types of aquifers and its initial properties. So you have this main flexibility across different units to add in the data for the tank model. Look into your observed data, and this is one of the most important ones to make sure we have data QC and validated. So you are able to use directly the observed data inside Petrel, just added here, and that will automatically compute your production data from your wells and create the field production parameters, oil, gas, water, injected volumes, and also static pressure points available and required for the material balance analysis. Once that is done and you're able to create the tank model, you'll be seeing these different plots, which will allow you to analyze your material balance model, starting with Havlena-Odeh plot, the energy plot, and the PZ plot. The Havlena-Odeh plot is a plot that will allow you to back calculate what will be your original in-place volumes in terms of oil, what will be your gas cap ratio, and also your aquifer parameters. And once you create your tank model, it will be located in the input pane, and then you can validate it from your analysis of the tank model created. What is the original in place and gas cap ratios? Look into the energy drive plot. So this is an example of an energy drive which allows us to identify what is the drive mechanism is currently present in my reservoir through this material balance study. So it is a plot that will be time dependent. So this is the start of the production, this is the end. And we'll be showing you as a percent of 0 to 1, what is the dominant drive mechanism. So the legend here is a legend in Petrel, and you have that as that legend here explained. So in orange, we have main expansion of the oil zone as one of the main drive mechanisms. In yellow, we have gas cap expansion, and in green, we have rock expansion. So look into this reservoir as it's producing through time. Those are the three main drive mechanisms from the beginning until the end of your historical data that are contributing to your production. One example, if you, for example, have water injection for 5 years in this field, and you're not able to see here has a contribution to your drive mechanism, then we have to revisit and actually see if that process is being implemented, or maybe your water is just being cycling. So it's very crucial to understand what is the drive mechanism we have in the reservoir and cross-validate that with the strategies to develop it. Also, you have the PZ plot, which will allow you to compute what will be your original gas in place. Basically, the PZ is for gas fields, and you can also have that diagnostic created through Petrel and have the back calculate input gas in place. So this is very valuable because you can cross-validate with your model and see if it's aligned, if it's not aligned, and if not, take the necessary measurements through uncertainty and understand the impact of having different volumes in place. Now here is a summary. Those are the three main outputs we have from the tank model analysis. So, and this is the value of be able to do material balance in Petrel, because that will quickly give you insights with the data you already have in your model, but will give you additional confidence and reduce the uncertainties if they are present on those specific parameters. Now, the other thing that the material balancing side Petrel plugin does is the calibration. We know that we may create the tank model, but even though it is not matching the pressure depletion or the pressure profile. So we have a process which is the calibration, which allow you to, using different parameters, input parameters has uncertainty, and be able to calibrate your tank model to match your pressure decline. And here we have the example, how does it work? So we'll see that in the demo soon, but what you have to do is basically adding the tank model you have created and specify the main uncertain parameters that you have, its minimum, maximum values, and calibrate the model in order to match your tank into your pressure decline. So this is a very valuable process, because using the analytical methods and be able to calibrate your pressure can also give more confidence on the drive mechanism and the initial in-place volumes associated with this tank. And one very good thing of being able to do this in Petrel is that you can cross-validate with your numerical simulator if it is either Eclipse or Intercept. Looking a little bit to the influx part, so the type of aquifers that is supported today inside this material balance are the ones that are here, from the Frekovich aquifer, the Van Everen aquifer are present. Also, for the gas field, we have the gasifer, which allows you to add in an influx of gas as well to be able to model your tank and represent the field behavior. So through that, I will want to go to a demo so we can demonstrate how does material balance work.
The material balance workflow in Petrel has 3 parts to it. The first one is the creation of your tank model. The second is visualizing the results of your tank model. And the third is calibrating the results obtained from the tank model. So before you proceed with to the workflow, you have to ensure that you have certain pieces of data already available in your project. Okay, so the first one is your historical production data, which will be stored in or as an observed data set. You'd also need a fluid model, which should be black oil. And what you also need is information on your static model, as well as some info on your rock properties. So what you'll see is that I do have a model already in the project. So this is a dynamic model which has been run with Eclipse. And I'll be comparing the results of my tank model to this model. Now, to begin the workflow, what you'd need to do is go to the production domain tab of your Petrel project. And in this group, material balance, you'll notice that we have 3 different sets of tools. And all of this will be used as part of the workflow. Now, to create the tank model, click on Create Tank. So once the process is opened, you'll see that we have 2 tabs, the Settings tab and History. And in the Settings tab, Petrel allows you to provide information around the properties of your reservoir. Okay, so the first would be to select what kind of reservoir you have. In my case, I'll be using an oil reservoir, but if you have a gas one, then you can go ahead and select gas. What you then need to do is provide your fluid data, which for me is this black oil fluid model. I'll also populate my reservoir pressure, my datum elevation, as well as my reservoir temperature. My GOR is 2.4 and my rock compressibility is 2.7 to the -6. Now, once that is complete, you can now move on to specifying the volume of your tank. So Petrel allows us to do this in a lot of different ways depending on what information you have or what input data you have for this. The first way is to simply specify this by typing it out as so. And this will be what you've obtained from the geoscientist. And you can populate the information on your reservoir porosity, your connate water saturation, as well as your gas cap in this manner. The second way of doing this is by using your contacts. So if you have an idea of where your different contacts in the reservoir are, you're able to specify all that information here by typing. The third way is by using a volume calculation case, which can easily be created in Petrel. So if you have that in your project, you can drop it in to this box over here and manually specify your reservoir porosity and connate water saturation. And the last way to do this would be to use your static model, which, as I mentioned, I do have already. So how you do that is by adding your grid as such. You'll notice that there's 4 different segments, which are basically the different compartments I have in my reservoir. So this tank is being computed for segment 1. Since I do not have a gas cap, my initial gas cap ratio is 0. And when it comes to providing your porosity as well as your connate saturation, Petrel actually allows you to type it out if you know what the average is. Otherwise, you're free to use the modeled porosity that's already in your project. And the same applies to your water saturation property. So Petrel also allows you to specify an aquifer if you suspect that you do have one in your reservoir. Okay, and how you do it is by coming to Influx and selecting aquifer. And you'll see that there's a whole list of aquifers that you can select. And for that, you'll have to specify your parameters. So for my reservoir, I do not suspect the presence of an aquifer, so I'll proceed with none. Now, once this is complete, you'll then move on to the History tab to provide your historical data. So since I already have an observed data set in my project, I will choose my second set of data, and it will populate the spreadsheet for you. Okay, so on every date, you're able to see what your cumulative production is. If you do have injection, you'll be able to see it for the different phases. And lastly, this is the reservoir pressure for each date. And once you're satisfied with your inputs, you can apply, and just to check to make sure that everything is correct and you've provided the minimum amount of information required by this process, you can go on to test. Okay, so it looks like everything has been specified well. So the next thing to do would be to run the simulation of your tank model. Perfect. So once that is done, you can go on to visualize the results, which will be stored for you in your input pane under the material balance folder. So what you should be able to see is tank 1 as well as your energy plot and the Havlena-Odeh plot. To visualize that, you would need to use a function window, which I will pull out, and just to maximize the space of this display, what you can do is stretch this box and click on energy plot, and this is what you'll see. And this basically shows us what the predominant drive mechanisms are in our reservoir at each point in time. So just to mention to you that all of this should add up to 1, right? Otherwise, if it doesn't, then it means that the information you specified in your tank is incorrect. The codes for this definition are all available in your material balance manual, which should be available in the installation folder. And this will give you guidance in terms of what each code means. What you can also visualize in this plot is the Havlena-Odeh. What you will see is that it will present you with a straight line which goes through your origin, right? And the information we can get on this is the oil in place, which will be displayed in this box over here. And we'll also have an idea of what the gas cap ratio is, should you have a gas cap in your reservoir. And if you wish, you're able to fit a straight line here to give you the parameters basically that make up the equation, should you wish to. And you could easily do that by creating a fit line, and you would be also able to get the equation by coming to here. You can use it for extrapolation purposes if you wish. Okay, so what we can also do is visualize the simulated oil production, gas production, as well as pressure, okay, from our tank model and compare it to our historical data. So if we plot that, this is what we see, right? So our production data is in agreement, but we can see that the pressure is not properly matched, right? And in the same breath, we're able to compare that to the result of our Eclipse run, which is this one over here. And if I were to plot that, here we go. So the production is good. And once again, the pressure is slightly above what the observed data is giving us, right? So the next thing to do now would be to calibrate our tank model to see which uncertain parameters can be modified in our reservoir model to match our pressure. Okay, and how you do it is by coming to calibration, still part of the material balance group. And the input would be, of course, our initial tank that we've created, right? And in this area over here, you'd be able to select the uncertain parameters. So a word of caution, it's always good to have as few parameters as possible at a time to see the impact of those on your overall result, right? So in my case, the parameters which I'm very uncertain about are my initial GOR and my reservoir porosity. So what I'll do is select those from there. I'll put in a range of values which I suspect the correct value will fall within. And for GOR, it will be 2, the maximum value of 2.9. And I'd like for the iteration to start at 2.4. And I'll do the same for porosity, where the start value is 0.5, the maximum 0.18, and 0.16. Apply, test once again. Just checking, and then you run it to output for you the calibrated tank with the updated results. It's almost done. Okay, great. So what you'll see is that it's going to show you your change from the original value by looking at the cells towards the right? And these will be updated in your tank model. Okay, so just to look at the results from that calibration, I'll just plot again our production data and include the calibrated tank. So what we now see here, especially with pressure, because it's where we had a lot of mismatch, we can see now that the updated model gives us a better approximation of our pressure match. So basically what this means is that we can update our grid using these parameters that we found as uncertain, right, to give us a more accurate geo model or simulation model. And to conclude, this is basically how the workflow for material balance in Petrel can be completed. So I'm going to hand over now to Henio, who will take you through the rest of the presentation.
Hello, thank you very much, Ndivhuwo. I hope you can hear me and see the slides.
Yes.
Okay, so now I will take you through the other station suite plugin, which is the EOR. But I'll just do a very quick introduction, the need that we have to use EOR and what is EOR. EOR is the enhance or recover, and basically is used to allow us to increase and maximize the recovery of oil. And normally it is denominated as a tertiary recovery method because allows and implement strategies like thermal reservoirs, different methods, miscible gas injections, chemicals, and other surfactants. Normally is implemented in a reservoir for mature fields, but today we have seen worldwide that different reservoirs where we have EOR being already planned in the beginning has a started strategy to develop the field. So we have three main types of recovery: primary, secondary, tertiary, and EOR is normally left to the end because it's the most challenging and costly as well. And I would like to show you a little bit of the roadmap to the decision making of an EOR method. Is a slightly longer process. You see here a cross plot showing risk in your vertical and effort and investment on the x-axis. And you can see that just to be able to mitigate, to minimize the risk, we have to do a lot of effort in screening, analysis, and planning from simulation and optimization methods to be able to understand it and be able to reduce. After that, we go for detailed laboratory studies to check which the method, the most suitable method, if it is feasible. We go for a pilot test in the reservoir, and we do a pilot injection to see if the result is as planned. And after we go for full field deployment. EOR help us to actually speed up the first step of an EOR decision, which is the field evaluation and screening, because that can take a long time and require a lot of resources in simulation and process. And this EOR plugin allows us to fast track and speed up, and using a standardized workflow to be able to address this first step of the EOR decision implementation decision making process. So EOR screen and decision making plugin in Petrel allows us to speed up this field selection and screening process. But how does it work? And how do we choose? So how does this EOR screening and decision making? So first of all, what we do, we want to be able to characterize the agents, the different methods that you can use with your reservoir. So we have to better characterize the rock properties, fluid properties, depth and temperature, and also to understand the connectivity of your reservoir for better sweep efficiency. and be able to select which agent will be most suitable according to availability, and also take into account your surface constraints. Through that, it's very important to consider the geological settings from the rock quality, which has a big impact in the success of the EOR method, and also your aerial connectivity and wide range distribution of the rock quality. Take into account of different depositional systems. For example, if you have fluvial, braided, or meandering systems, or shallow marine system, which method, this also has a big impact in the connectivity and mobility of the oil, plus your main fluid properties. So one thing that is important to mention is that from the EOR method and its implementation, it's very important to understand not only the aerial heterogeneity, but also the vertical one, because that could that could be the reason of applying different EOR methods in different sections of your reservoir. Also take into account the rock quality of each of these individual sections. So it is a quite complex study that we need to be able to do in terms of screening and understanding which EOR method and which sweeping strategy and which rock types it impacts. So the EOR plugin in Petrel, we can use it in two different types of reservoir. First of all, we can use the normal clastic reservoirs. When I mean clastic, it's not only clastic, but single reservoirs, not fracture. And through that, we'll go to the process of workflow, which is summarized here by this network of process, which I'll go in detail later. We also have the natural fracture reservoirs, which is mainly for carbonate. So this method is able to be implemented in both of these type of reservoirs, if you have them. Now here I would like to summarize a little bit in detail the process and the workflow. First of all, everything starts with the good data loading, quality, and validation. It's crucial that we align and we make sure that the input data is accurate. And also we have the data required to perform this process, from the PVT analysis for the full scale, detailed scale analysis, and also the reservoir properties. If we have a fracture reservoir, for example, need to have a good understanding of both fracture and matrix, at least to be representative. So after that, we go for data interpretation. So basically is understanding which agents could be used, take into account your geological settings, rock type, and fluid, and which geological structure you have in place. And after that, we go for the step, which is the screening. This is combining the EOR agent that you have, your geological properties, your physical properties, and one thing that actually gives real value to this EOR screening tool is the comparison of interest of more than 2,800 successful and not successful case in the industry. So that means that more of just inputting the data and selecting which process and which rock quality you have, it will cross-check with different EOR methods implemented globally, and we also be a parameter of validation if the EOR process we are suggesting is doable and can be implemented, if can be worked, and we have a reference to it. An additional one, which is still being further developed, is to be able to perform industry forecast. Sorry, can you hear me? I just want to confirm.
Yes, we can hear you.
Yes.
Okay, thank you.
Yes.
So I know we are rushing in time. I'll just speed up so we can conclude. So here we have different screening solutions. First of all, for quality and quantitative. So quality will be the examples of worldwide industry implemented EOR methods. And quantitatively will be with a numerical simulator, which could be Eclipse, and also analytical methods inside the EOR process. And that allows you to be able to have and enable to take decision making on your EOR pilot process. And here I would like to really enhance or let's say reinforce the potential that the reservoir may have in terms of displacing efficiency, which is taken account into this workflow. And one thing that is good is to maximize the reduction of the uncertainty in the process of decision making of the EOR method. So the EOR processes that are available today are these ones we have here, which I'm showing from the alkaline, CO2 form, hydrocarbon miscible or immiscible injection, nitrogen, polymer, surfactant, steam. So what this process will do, we will rank from each one of these methods, take into account all the input data that you have, which method will be more suitable for your reservoir, for your different rock types inside the reservoir, if you have a high geological heterogeneity, and also fluid type. So through that, I'll just show you a quick video with the process. I do apologize sometime, but this will not take me long. So here is just to show you how does it work. So first of all, in Petrel, you go to the main reservoir tab, and you have the EOR screening process. So here is where you select, and we'll open you this window. So this is the EOR screening tool. What you have to do is import your model, and it's important to state here that has to be a history match model, because that will give you more validity of your process you want to add in. The same process you do it in Petrel. So you add the data file, you open, you import, same methodology. And once you have imported, you'll be able to select the main characteristics of the process that you have. You want to do WAG, thermal injection, thermal, or even if you have geological heterogeneity present. So you select yes or no, depending on which type of model is a reservoir. It will QC and validate if all the required data is available to you. If you don't have a numerical simulator, then you have to put out this information manually, your PVT, your SCAL, and also your main strategy to implement. You can select which date from your numerical simulator you want to start the EOR process, and define the main potential evaluation, the number of years you want to do it. Once that is done, you move into the next parameter where you can characterize what is your formation settings. Once that is implemented, you can quickly QC your input information. These automatically will come for your fluid model, which is in the Eclipse deck, and you can cross-validate the input both for the fluid, also for the EOR parameters that you will define. And by clicking next, you will be able to select. So this is a questionnaire which will ask you which methods, if you have gas lift, which characteristics you have in your reservoir. And then it will validate all the information you put has the input, and it tell you which information is not viable or is not complete, so that you can optimize. You click and calculate through this process. And then you'll be going to the reservoir characterization, where you can screen both the reservoir quality of your sessions and also the mobility for each one of these sessions. So once you validate through this process, you'll be able to see the statistics. If you have different wells, you see which wells are actually in this section of the reservoir. And then you'll be able to assess on the screening part, the compatibility. So that is from the pore scale, from the macro scale, and also from the industry guidance examples existing today, which are part of this catalog. So in here, you'll be able to QC. Green means you have good correlation, is good and is variable to be implemented to this field, and you can quality check each one of these parameters for each individual area of your reservoir. Clicking next, as part of the screening, you'll be able to see which method is suitable for a specific formation. In this case, from the Argentine you have there, you have foam and WAC. And once you completed the process, it will automatically generate a report to you, which has all the specifications of your EOR process that was used, and also the results and the validation of the EOR tool. So this is a very straightforward process. What you need initially is having a numerical simulator to make it fast, and an understanding of which method you believe could work as initial step, and be able to walk through the process. Important to understand your geological heterogeneity and also your fluid parameters. And through that, it will cross-reference with industry, with more than 2,800 projects of EOR globally, and associate which one is similar to your formation or not. And that will show you the main compatibility of this EOR tool. At the end of this report, automatically generate for you, it will create a top 2, top 3 process that can be implemented in your field. With that, I would like to finish the presentation. I do apologize on the time, but if it's okay for you, we can take 10 minutes so we can answer the questions that you have.
Okay. So, Henio, do you want me to read the questions, and then either you or Samuel can take the answers? Maybe we go
yes,
the
please.
chat. I'll go in the chat window from the top. So there was a question from Laila. Can Petrel also handle unconventional reservoirs, CBM reservoirs that undergo a desorption, to be specific?
So yes, the answer is yes. So the thing is, if you are able to model these reservoirs, sorry, it was on the, apologies, was on the material balance?
Correct, yeah, on the material balance.
Okay. So for the material balance, basically, the concept is to have the tank. And to create the tank, you need just simple properties, average porosity, average water saturation, and the volume. So if you have a model in Petrel, could be one of the fractal model, for example, or a normal clastic models or unconventional models. So what material balance will do, if we input the grid in to create the tank model, it will define the volume of that grid and the average properties of the areas that correspond to your tank. And that is what will be used as input to create your tank model. So the answer is yes, if you have the model characterized in Petrel, and you can use that grid to input. And what Petrel workflow will do, will take the average properties from this in order to create the tank, which will later be used for your material balance calculation.
Okay, so the second question is from Yesi. Could we link directly with our former MBAL files, or we have to restart all the process from scratch?
Well, one good thing is you cannot link everything, but if you have your MBAO files where you have the details, the input parameters of your model, such as the volumes, the petrophysical properties, the fluid characteristics, you can justly import it into Petrel. And through that, you can exactly replicate what was done in your MBAO. So this is one way that can be done. Also, let me say, for example, you have your fluid model parameters in a spreadsheet. You have your production data in a spreadsheet. You can easily import that into Petrel, and through that, already apply into your material balance calculation. So there is some small workflows that you have to do to make sure your Petrel material balance is consistent, but there's no direct link to automatically convert one to the other.
Okay, thank you. So another question from Talaji, do you need relative permeability for the material balance?
No. For the material balance, there is no need to input of relative permeability parameter as a whole. Okay. Now we need to add in the raw compressibility, and so let me put this way: you do need relative permeability because there are few parameters which are crucial, which is the critical water content water saturation and your compressibility. So if you have a petrophysical model with your water saturation distribution, so you can directly use that in Petrel. Otherwise, you need to put what is your connect water saturation. If you have your raw compaction as part of Petrel, that automatically takes it into the material balance calculation. If you not, like Ndivhuwo was saying, you can manually specify what is your raw compaction. But other critical parameters and irreducible parameters you don't need for this material balance calculation.
Okay, great. So from Esperanca, does the plugin allow multiple pools / tanks simulation simultaneously?
Exactly. So all of those are very good questions. So this is another one. Up to the moment, this method does not allow yet multiple tanks. This is something our team is continuing is developing to be released in the next versions of Petrel, but allows you to select different tanks as you do the calculation. So for example, you can create tank 1 for one specific zone of your reservoir and tank 2 for the other zone, but there won't be any interaction within them. This is what will be developed on multi-tank for the next release of the material balance.
Okay, great. So Stephanie is asking, is it possible to show the legend just so we know exactly what we're looking at? Okay, I think that was about during the demo. I think that's maybe passed already. Yeah, and then there was the issue with the lag. It was resolved, and then I'm scrolling down to the questions here. Okay, so during the demo there was the question on the porosity 0, so it was not clear for many of the.
Okay.
Yeah.
So basically, porosity 0 was just the name of a property in Petrel that we use to create the material balance calculation. So basically, that is just the name of the property we use, of the static property we use as input. The porosity value is not 0. That was just the nomenclature we had in Petrel. So, and I'll just restate here again, there are two ways you can put your data. You can just put an average value, or you can use the property, porosity property, computed by the petrophysics with the main heterogeneities that are present in your model now, and automatically create an average from those. That gives more certainty, let me put it that way, on the real average value that you have. So the porosity value is not 0.
Okay, okay, good. So I think from what else? In the water drive system, would you be able to transfer the aquifer model used in MBE straight into your dynamic model?
To be able to transfer directly, not, but you can use the properties of your aquifer and replicate these properties in the material balance process. Now, if you have an aquifer model in Petrel, for example, you are not able to automatically drag that aquifer to your material balance yet. This is something that is being working on, but you can input in the main parameters, either if it's Freckle-Fritz linear aquifer, for example, you can input in the same parameters to be able to replicate the same aquifer influx response and pressure support to your reservoir.
Okay, so just to highlight for the audience, yeah, if you have a question, you can just raise your hand. There is an icon here to raise your hand, and then we can ask you to unmute and say your question, right? While we take more questions from the chat box. There is one here. Yeah, it's wonderful to see MBE integrated into Petrel. However, I wonder if there is a possibility to run a forecast after production data matching.
Exactly. So another very good question. So right now, it's not possible yet to run forecasts from this material balance tool. There is other ways of performing and doing analytical forecasts. This will be covered in other sessions from the RTA and analytical modules. So this will be actually the next session. We'll focus a little bit on the forecast from analytical models. But from the material balance itself, in Petrel, there's not yet the forecast, only the tank model generation and the calibration process too, which allow you to refine and optimize through the using an uncertainty engine. And this will give you the tools and the parameters which you then try to optimize your numerical simulator. I just want to enforce here one thing, that the big value to put and add in the material balance tool in Petrel is not, for example, to perform all the material balance tasks that other simulators do, but is to be able to assist you in your decision making much faster. So if you need to cross-validate your analytical model with your numerical model, you can do that directly in one simulation window result and see the impact of any analytical tool that may have in your numerical simulator too. And it's still being adding new developments to be able to perform more tasks. But the big gain is that you can do your material balance model very quick, very easy, and using the information you have there in the project. Forecasting will be a next step into that.
Okay, so I think there's maybe the last question. Mr. Charles is asking to see the control parameters and the constraints for the rate calculations, how they are set up in the material balance plugin. Maybe this is maybe something we can take offline with him in more details, right? If I think maybe if he missed that demo. Yeah. Yeah, I think that's most of the questions. The recording is made, and it will be made available to most of you guys after the presentation. This slide is showing now the list of the next technical sessions. So back to you, Henio, if you want to make any closing remarks.
Okay, so what I want to add is, first of all, I would like to thank all of you for the time, and one more time apologize for the late. Although this first session and the next sessions to come, so we'll be covering different aspects of your Petrel workflow. So we encourage you to join, or also if you have additional questions on these workflows, do not hesitate to contact us, send us an email. we'll be able to answer you in more detail. And if you have suggestions of other sessions that would be interest for you or your company also, please do let us know. And through that, I would like to thank you all for your disponibility to be able to participate. And I hope that sharing this workflow with you will help you allow to, number one, try implementing your fields if that is the case, and also optimize your process and be able to make quicker decision making, more integrated, more robust, and faster. And this is our goal, look into this new way of working in the future. Thank you very much, and have a good day and stay safe.